My name is waterkh. Welcome back. We're going to be doing an ADFGX update today. If you don't know what the ADFGX is, I'm going to be putting out a video in the future going a lot more in detail and in depth into what this cipher is. But if you've been in the zombies community for a couple years, then you probably know about the Mob of the Dead ADFGX cipher. And I just looked it up because I don't really know release dates, but it's been 5 years in April. Like since April, it's been 5 years since this map's been released and since this cipher has been unsolved. I know heaps of people have tried to solve this, Telexion, Mr. Awful Waffles, but it's still been unsolved 5 years later. Right now it's pretty much just me and Oxen8 who are currently working on this. He's working through his own solutions, I'm working through mine. I might have him on the channel sometime to talk about his, or he might just update you guys on his own channel. Now, one idea I did have was to go back through all the different solutions that I have, like partial code that I built out and stuff in my repositories to pull out and sift through and go through with you guys. But in this update, I'm just going to be talking about what I'm currently working on, which is what I call a double dictionary attack. And if you don't have a computer science background, dictionary is just a key value pair. So you have something that gives you something else. So like a key to a lock, pretty much. In this case, my keys are going to be an index and then a word length, and both of those keys are going to give me a word. Now in the background, I'm just going to have the current attack that I'm implementing at the moment while I go over some of the details and also hopefully put up some graphics so it can be easier to follow what I'm saying. For this attack, we really just need a good word list, something that includes zombie words and also very frequent words. So this approach isn't complete yet. I still have some odds and ends to fix, a few bugs here and there, but for the most part I have the theory down and the general idea of what I want to get out of this and also how I want to approach this problem. So now I'm setting everything up for the attack. So what I need to set up for is I need my data, which is comprised of knowing the index and the word length, and then also what words are going to fit in that index. So I can walk you through basically what this for loop here looks like. I'm going to start at 0, so that's going to be my index 0, which is going to be I. And then I'm going to go through each one of my words from my word list. And I'm going to remove all the special characters, and I'm going to convert it to an alpha pattern. So basically, to explain alpha patterns, I'm going to use an example. So if we have the word apple, then the alpha pattern for that word is going to be A, B, B, C, D. A, P, P, L, E. So I'm replacing all the unique letters with letters from the alphabet starting from A. Now that I have our word alpha pattern, I'm going to make also a substring of our ciphertext from our current index to however long our word is. I'll put a graphic on screen kind of to explain this, but basically I want to start at that index and then get however far our word is so that we can match it. And that's what we're going to do in the next line. We're going to compare our alpha substring and our alpha word, and if they match, that means our patterns match, because if let's say apple is what would fit in that alpha sub. So if alpha fit there, then APPLE or ABBCD would equate to alpha sub. And then we would add it to our dictionary that we're holding for all these words that are going to fit in that index with that word length. So now that we have all our data in one place and we know we can access it with the index and the word length, now it's time to attack. Now what I'm doing here is I'm setting up this attack so that I can recursively go through. And what that means is basically I can just iterate through the top length of the word one time and then set my program to just do it until it gets to a certain depth. It's pretty complicated, so I'm not going to get into it here. If you want to comment down below, maybe we can discuss it somewhere else. Or I can make a separate video if you guys are into programming or need some programming help. But basically setting it up this way, I can just write it once and then iterate through it until I hit a certain depth. So this is basically just assigning a ciphertext letter to a distinct letter that we're going to be using in our attack. And so this just makes sure that we assign one letter to one letter. And so we don't have multiple likes. So A can't equal B and C. It can only equal B. And that's what this key system is going to be doing. So it's going to recursively go through, and each time it goes again, that just means we're adding another word to our plain text. So once we hit 8 words, then we can kick out and we can print that plain text to a file. So it may look complicated and it may sound complicated, but essentially we're just making all these possibilities and then we're just limiting those possibilities further. As I think I've mentioned it before, there are still some issues with it. I'm not printing out any data yet, so I'm limiting it too far. One of the fixes for that is to make it so that I can allow some words not to be filled. So I can skip like X amount of spaces and then continue from there. But I hope you guys enjoyed. I'm going to be doing an ADFGX cipher video, not soon, but in the near future as part of our cipher tutorials. It basically merges a substitution cipher and a transposition cipher together, which we'll be discussing actually this week and then next week. If you guys liked the video, then subscribe. We'll be doing these kinds of videos hopefully every other Sunday. If I do like a shorter video like this time, I might do another video next weekend. If you guys have any comments or questions, please just let me know down below and I'll do my best to answer them. See you guys in the next video.